June 6, 1944, 06:30 hours, Omaha Beach, Normandy, France. Oberleutnant Franz Gockel stood in the concrete bunker, designated WN-62, binoculars raised, watching the grey morning sea through the firing slit. He'd held this position for 18 months, commanding a reinforced platoon, defending the bluffs overlooking what the Allies would soon call Bloody Omaha. His diary entry from the previous evening read, "Another day of waiting. The Atlantic wall stands impregnable. When the invasion comes, we will throw them back into the sea." In 30 minutes, he would watch American DD tanks, floating tanks his superiors had mocked as impossible engineering fantasies, emerge from the waves and crawl toward his position, bringing 75mm guns to support infantry his bunkers were designed to massacre. The German High Command had laughed when intelligence reports first described Allied amphibious tanks in 1943. The reports seemed absurd. 30-ton Sherman tanks equipped with canvas flotation screens, propelled through water by twin propellers, capable of launching from landing craft thousands of meters offshore and swimming to the beach under their own power. German engineers who reviewed the intelligence dismissed it as Allied disinformation designed to mislead defensive planning. Tanks couldn't float, the physics were impossible. A 30-ton steel vehicle would sink immediately upon entering water. Even if flotation could somehow be achieved, the tank would be helpless in ocean swells, unable to navigate, vulnerable to every wave. And the idea that such vehicles could provide fire support during the critical first minutes of an amphibious assault, when attacking forces were most vulnerable and defensive positions most effective, was pure fantasy. The Germans built their Atlantic wall defenses on the assumption that Allied armor would arrive on the beaches long after the initial assault waves had been destroyed. Infantry would land first, unsupported, facing concentrated fire from prepared positions. German machine guns, mortars, and artillery would massacre them in the surf. By the time Allied tanks could be landed from LSTs, landing ship, tank, and driven up the beaches, the invasion would already be defeated. They were catastrophically wrong. On June 6, 1944, DD tanks, Duplex Drive tanks, officially Donald Duck tanks to the soldiers who crewed them, swam ashore at 5 Normandy beaches, providing immediate armored support that German defenders never expected to face. The psychological impact was devastating. German infantry, who'd prepared to slaughter helpless Allied soldiers, instead faced 75mm tank guns firing from vehicles that had emerged from the sea like mechanical monsters. The doctrine of static defense, German defensive doctrine for opposing amphibious invasion, rested on Field Marshal Erwin Rommel's philosophy: defeat the enemy on the beaches before they could establish a foothold. Rommel had been appointed commander of Army Group B in late 1943 with orders to strengthen coastal defenses along northern France. He'd inspected the existing fortifications and concluded they were inadequate. Rommel's strategy was simple and brutal: concentrate maximum firepower on the beaches, create killing zones where Allied forces would be completely exposed, and destroy the invasion during the critical first hours when attacking troops were most vulnerable. He ordered construction of extensive beach obstacles: steel tetrahedrons, wooden stakes topped with mines, Belgian gates designed to rip open landing craft hulls. He positioned machine gun bunkers to provide overlapping fields of fire across every meter of beach. The key assumption underlying Rommel's defensive strategy was timing. Allied infantry would land first, unsupported by armor. The troops would struggle through beach obstacles while German machine guns and artillery fired from prepared positions. Casualties would be catastrophic. Rommel estimated 90% losses in the first wave. Complete destruction of follow-on forces and invasion failure within 6 hours. Allied tanks would arrive later, after infantry had secured the beaches, if any infantry survived. Landing ship, tank vessels would beach themselves, drop their ramps, and disgorge 30-ton Sherman tanks directly onto sand. But this process required calm seas, secure beaches, and time, all of which Rommel intended to deny the Allies. German intelligence estimated the Allies would need at least 4 hours to land significant armor after the initial infantry assault. 4 hours during which German forces would slaughter unsupported infantry, destroy landing craft, and prepare to engage Allied armor as it struggled up the beaches through destroyed vehicles and under concentrated anti-tank fire. The timeline seemed to guarantee defensive success. German officers who reviewed the defensive plans expressed confidence bordering on certainty. General Oberst Friedrich Dollmann, commanding 7th Army, wrote in April 1944, "The Atlantic Wall fortifications make successful invasion impossible. The enemy will land infantry without armor support. We will destroy them in the surf. By the time enemy tanks arrive, if any survive our preliminary bombardment of their shipping, the invasion will already have failed." When intelligence reports in early 1944 described Allied swimming tanks, German reaction ranged from amusement to contempt. Major General Wilhelm Richter, commanding 716th Infantry Division defending the Normandy coast, reviewed the intelligence reports and wrote in his assessment, "The British claim to have developed tanks that can float and swim to shore. This is obvious disinformation intended to mislead our defensive planning. Tanks weigh 30 tons. They cannot float. Even if the British have developed some experimental flotation system, such vehicles would be helpless in open ocean, unable to navigate in any sea state, and would provide no combat capability during the critical assault phase. We should dismiss these reports and focus on realistic threats." German engineers who analyzed the concept agreed with Richter's assessment. They calculated that providing sufficient flotation for a 30-ton tank would require buoyancy chambers so large the vehicle couldn't fit on landing craft. Propelling such a vehicle through water would require engines and propellers that didn't exist. Navigation in ocean swells would be impossible. The tank would capsize in the first large wave. The concept violated every principle of marine engineering. Ships floated because they displaced water equal to their weight. Achieving this with a tank would require building a boat around the tank, negating any tactical advantage. The intelligence reports must be deception, perhaps covering the real Allied plan to develop specialized landing craft that could drive closer to shore before disembarking tanks. German defensive planning proceeded on the assumption that Allied armor would arrive hours after initial infantry assault. The assumption shaped defensive tactics, weapon positioning, and obstacle placement. It was the foundation of the entire Atlantic Wall strategy. It was wrong, the impossible engineering. The DD tank, Duplex Drive tank, was the brainchild of British engineer Nicholas Straussler, who'd been developing amphibious vehicle concepts since the 1920s. Straussler understood that tanks couldn't float using their hull buoyancy alone. The steel hull was too dense, the internal volume too small. But he recognized that flotation could be achieved by surrounding the tank with a buoyant screen that displaced enough water to support the vehicle's weight. The solution was elegantly simple: a collapsible canvas screen attached to a steel frame mounted around the tank's hull. When raised, the screen extended upward approximately 6 feet, creating a boat-like structure around the tank. The canvas was waterproofed and supported by 36 pneumatic struts that could be inflated in 15 minutes using compressed air bottles. The result looked absurd, a tank apparently wrapped in a tall canvas skirt. But the physics were sound. The screen displaced approximately 100 cubic meters of water, providing sufficient buoyancy to support the tank's 33-ton weight with several tons of reserve freeboard. The tank's center of gravity was low, most weight concentrated in the hull and turret near the waterline, providing stability in moderate sea conditions. The canvas was flexible enough to flex with wave action without tearing, and the frame was designed to collapse quickly once the tank reached shore. Propulsion came from two propellers mounted at the rear of the tank, powered by the tank's main engine through a power takeoff system. The Duplex Drive designation referred to this dual power system. The engine could drive either the tracks, for land movement, or the propellers, for water movement, through a transfer case operated by the driver. Maximum water speed was approximately 4 knots, slow by naval standards, but adequate for covering the distance from landing craft to shore. Navigation was primitive but functional. The tank commander used a standard magnetic compass and directed the driver through the intercom system. Steering in water was accomplished by varying propeller speed. Increasing power to one propeller turned the tank toward the other side. The system was clumsy and required constant attention, but it worked well enough for the short distance between launch point and beach. The first DD tank prototype was tested in June 1942 at Henley-on-Thames. British Army engineers lowered a modified Valentine tank, lighter than the Sherman that would eventually be used, into calm river water. The screen held, the tank floated, the propellers drove it forward at walking speed. Everyone involved was simultaneously amazed and terrified. The tank sat low in the water with only the canvas screen and turret top visible above the surface. It looked like a floating bathtub, unstable and vulnerable. Waves from passing boats caused the tank to roll alarmingly. The crew felt like they were riding inside a boat made of cloth, acutely aware that 30 feet of water lay beneath them, and only canvas prevented the tank from sinking. Testing continued through 1942 and 1943, gradually increasing sea states and wave heights. The DD tanks proved remarkably seaworthy in moderate conditions, capable of operating in seas with waves up to 3 feet, winds up to 10 knots. Beyond those conditions, the tanks became unstable, at risk of swamping if waves topped the canvas screen or capsizing if hit by waves from the side. The limited seakeeping capability created tactical constraints. DD tanks could only be used if launched close to shore, maximum 5,000 meters, in relatively calm conditions, wave height under 3 feet, with wind and current accounted for in navigation. These constraints were acceptable. The tanks didn't need to cross the English Channel, just cover the distance from landing craft to beach, a journey of perhaps 20 minutes under ideal conditions. By early 1944, Allied planners had incorporated DD tanks into the D-Day assault plan. The British would land DD tanks at Gold, Juno, and Sword beaches. Americans would use them at Utah and Omaha beaches. The tanks would launch from landing craft tank, LCT vessels, approximately 5,000 meters offshore, swim to the beach, drop their screens upon reaching land, and immediately engage defensive positions. The tactical advantage was transformative. Instead of infantry landing unsupported and being massacred in the surf, they would assault under covering fire from 75mm tank guns that were already engaging bunkers, machine gun nests, and artillery positions. The armor would arrive in the first wave, not hours later, but simultaneously with infantry, fundamentally changing the dynamics of amphibious assault. German intelligence never understood this. Their agents reported unusual tank modifications, canvas screens, propeller assemblies, waterproofing. But German analysts interpreted the evidence as preparations for deep wading through water obstacles, not open water swimming. The concept of tanks launching thousands of meters offshore and swimming to the beach remained literally unthinkable to German military engineers. June 6, 0530 hours. The decision. Lieutenant Dean Rockwell, commanding a platoon of Company B, 741st Tank Battalion, stood on the pitching deck of landing craft Tank 600, watching the grey dawn sky and feeling his stomach rebel against the 6-foot swells. His platoon's 4 Sherman DD tanks were buttoned up, engines running, canvas screens inflated and straining against the wind. The LCT was 5 kilometers from Omaha Beach, farther than planned, beyond the safe operating limit for DD tanks in current sea conditions. The original plan called for launching 3,000 meters from shore in seas no higher than 3 feet. Current sea state, 6-foot swells, 15-knot winds, strong lateral current. Naval officers were recommending cancelling the DD tank launch and instead running the LCTs directly to the beach to disembark tanks conventionally. Rockwell faced an immediate decision: launch now under dangerous conditions or wait and lose the element of surprise. Company B's commander, Captain James Thornton, had already made his choice. We launch. The infantry needs us. We didn't train for 2 years to ride to the beach like passengers. The decision was both brave and tragic. At 0550 hours, the ramps dropped. The first DD tank rolled forward, canvas screen towering 6 feet above the hull, and dropped off the ramp into 6-foot swells. It floated, barely, wallowing in the waves like a ship taking on water. The second tank followed, then the third, then the fourth. Rockwell's tank was 5th in the launch sequence. He felt the tank roll forward, treads gripping the LCT's deck, then the sudden drop as they left the ramp. The impact with the water was violent, a bone-jarring collision that threw him against the turret interior. Then buoyancy caught them, and the tank bobbed to the surface like a cork. Water sloshed against the canvas screen, spray flying over the top, wind catching the screen and pushing them sideways. Rockwell stood in the turret hatch, the only crew position above the screen, using the compass to navigate while waves crashed over the canvas. He could see perhaps a dozen other DD tanks wallowing in the swells around him, all headed toward the beach 5 kilometers distant. The shore was barely visible through morning haze and smoke from naval bombardment. Then he watched one of the DD tanks ahead of him roll heavily in a wave and not recover. The canvas screen caught wind from the wrong angle. The tank heeled over, water poured over the screen edge, and the Sherman, 33 tons of steel, sank in less than 10 seconds. 5 men died without ever seeing the beach. Another tank swamped when a wave broke over the screen, flooding the interior. The driver tried to keep the engine running, but water overwhelmed the bilge pumps. The tank settled lower, the screen collapsed, and it too disappeared beneath the waves. 3 men escaped the turret. 2 drowned before rescue boats could reach them. Of the 29 DD tanks from Company B that launched from LCTs 5 kilometers offshore, only 2 reached Omaha Beach. 27 sank in the English Channel, vehicles that cost $50,000 each and required months of specialized training to operate, lost in 20 minutes because the sea state exceeded their design limitations. 116 tankers went into the water, 33 drowned. The disaster was specific to Omaha Beach and to Company A of the 741st Tank Battalion. At Utah Beach, DD tanks launched only 1,500 meters offshore in slightly calmer conditions. All reached the beach successfully and engaged German positions during the first assault wave. At the British beaches, Gold, Juno and Sword, DD tanks launched even closer to shore and provided immediate fire support that proved decisive. The difference was local sea conditions and launch distance, tactical decisions made by individual naval commanders that morning based on their assessment of weather and tactical situation. The Americans at Omaha made the wrong call, launching too far out in too rough seas. The British made the right call, launching close to shore in manageable conditions. 0630 hours, the monsters from the sea. Oberleutnant Franz Gockel watched the first assault wave approach Omaha Beach through his binoculars, counting landing craft through the smoke and spray. Higgins' boats loaded with infantry, some already disgorging men into chest-deep water. The soldiers struggled through surf and obstacles, exactly as German defensive plans anticipated. Gockel's machine guns opened fire, long sustained bursts from MG-42s firing 1-200 rounds per minute, tracers arcing down into the surf. The Americans fell in waves, cut down before reaching the beach, bodies floating in the surf or piling up behind steel obstacles. The defensive plan was working perfectly. The machine guns were killing the American infantry faster than they could land, creating the massacre Rommel had predicted. Then Gockel saw something that made no sense. Through the smoke and spray, approximately 300 meters offshore, he saw what appeared to be a boat heading toward the beach. But the shape was wrong. Too low in the water, moving too slowly, heading directly toward the beach rather than angling toward the obstacles. As it approached, the shape resolved. A tank turret with a 75mm gun, surrounded by what looked like a tall canvas fence. The object hit the beach, the canvas collapsed, and a Sherman tank emerged from the collapsing screen and began crawling up the sand, 75mm gun traversing toward Gockel's bunker. A tank had just driven out of the ocean. It had swum to shore under its own power. The intelligence reports had been accurate. The Allies had actually built floating tanks. The Sherman's 75mm gun fired, the high-explosive round impacting the concrete face of WN-62, shaking the bunker but not penetrating. The tank's machine guns engaged the bunker's firing slits, forcing German soldiers to duck away from their weapons. More DD tanks were emerging from the sea, 3, 4, 5 vehicles crawling out of the surf and engaging defensive positions. Gockel grabbed the field telephone connecting his bunker to the battalion command post, shouting into the handset, "They have tanks on the beach." Tanks came out of the ocean. Repeat, enemy armor is engaging our positions. The response from the command post was confusion. Impossible. Enemy tanks cannot arrive for hours. You are seeing amphibious vehicles or armored cars. Negative. Sherman tanks with 75mm guns. They swam to shore. They are engaging WN-62 and supporting positions. The battalion commander came on the line, his voice tight. "You are reporting that enemy tanks swam to the beach." "Affirmative. They were floating when I first saw them. Now they are on land and firing." Silence on the line. Then, "Engage with anti-tank weapons. I am reporting this to division." The initial shock was giving way to tactical adaptation. Gockel's position included a 50mm anti-tank gun, positioned to fire down the beach at vehicles attempting to advance from the waterline. The gun crew traversed onto the nearest DD tank, approximately 400 meters distant, still at the water's edge, and fired. The first round missed, kicking up sand beyond the target. The second round struck the Sherman's glacis plate and ricocheted off. The 50mm gun lacked penetration power against Sherman frontal armor at that range. The Sherman's 75mm gun responded, the round striking directly in the anti-tank gun's embrasure. The explosion killed 3 of the 4 crew members instantly. The surviving gunner crawled away from the position, temporarily deafened and in shock. The DD tanks were changing the tactical equation. Instead of infantry struggling alone through obstacles and machine gun fire, the Shermans were engaging bunkers and providing covering fire. Infantry that would have been massacred in the surf now had armored support. The Germans had prepared to fight unsupported infantry. They were facing combined arms assault. The psychological impact on German defenders was profound. They'd been told that Allied tanks wouldn't arrive for hours. that they would face helpless infantry they could slaughter at will. The appearance of tanks, mechanical monsters that had somehow driven out of the sea, was both terrifying and demoralizing. The defensive plan had been built on assumptions that were proving catastrophically wrong. The pattern repeats: Utah Beach. While DD tanks struggled and sank at Omaha Beach, the assault at Utah Beach demonstrated what swimming tanks could achieve under proper conditions. Company C of the 70th Tank Battalion launched their DD tanks from LCTs positioned only 1,500 meters offshore, well within the safe operating parameters for the vehicles. 28 DD tanks entered the water at 6:10 hours. The sea state was moderate, 4-foot swells, manageable wind, weak current. The tanks formed a ragged line and began swimming toward shore, propellers churning, canvas screens flexing with the waves but holding. Oberfeldwebel Klaus Weber watched them approach from his position in Strongpoint W5, defending the causeway exit from Utah Beach. He'd been briefed that morning about confused reports from Omaha Beach mentioning swimming tanks, but had dismissed them as combat stress causing hallucinations. Now he was watching the same phenomenon. 28 objects that looked like floating bathtubs, each topped with a tank turret, crawling toward his beach at walking speed. Weber reached for his field glasses, confirming what he was seeing. Those were Sherman tanks, definitely, with 75mm guns and the distinctive American star painted on the turret sides. And they were floating, moving through water too deep for wading, driven by some invisible propulsion system. The impossible intelligence reports were accurate. The DD tanks reached the beach at 06:33 hours, exactly on schedule, 7 minutes before the first infantry landing craft. They crawled up the sand, canvas screens collapsing around them like deflating balloons, and immediately began engaging German positions. The 75mm guns fired high-explosive rounds at bunkers, machine gun nests, and artillery positions. Weber's strongpoint took direct fire from 3 DD tanks simultaneously. High-explosive rounds impacted the concrete face, shaking the structure and filling the interior with dust and concrete fragments. The firing slits became death traps. Machine gunners who tried to return fire were immediately targeted by tank guns. Within 10 minutes of landing, the DD tanks had suppressed most of the defensive positions covering the beach. When American infantry began landing at 06:40 hours, they faced scattered resistance rather than concentrated fire. Casualties in the first wave were remarkably light. Fewer than 200 men killed or wounded out of 23,000 landed that day. The contrast with Omaha Beach was stark. At Omaha, where most DD tanks sank before reaching shore, the infantry faced unsuppressed defensive fire and suffered catastrophic casualties. Approximately 2,000 killed or wounded in the first hours. At Utah, where DD tanks landed successfully and engaged defenses before infantry arrived, casualties were minimal and objectives were secured ahead of schedule. The difference proved that the DD tank concept worked exactly as designed, when employed under proper conditions, with launch distances within operating parameters and sea states within design limits. The vehicles provided immediate armored support during the critical first minutes of assault, fundamentally changing the tactical dynamics of amphibious invasion. The British beaches, Vindication at Gold, Juno and Sword beaches, British and Canadian forces employed DD tanks with even greater success than the Americans at Utah. British commanders had learned from extensive training exercises that DD tanks required launch distances under 2,000 meters and sea states under 4 feet to operate safely. They positioned their LCTs accordingly, launching tanks close to shore in manageable conditions. At Sword Beach, DD tanks of the 13th 18th Royal Hussars launched at 07:30 hours from LCTs positioned 1,000 meters offshore. All 28 tanks reached the beach successfully and engaged German positions immediately. The tanks provided covering fire for infantry of the 8th Infantry Brigade, suppressing bunkers and destroying obstacles. Sergeant David Brown, commanding a DD tank in B Squadron, described the experience in his post-battle report. "We launched 1,000 meters out in calm conditions. The swim took about 15 minutes. We could see the beach clearly, identified our targets while still in the water. We reached shore, dropped the screen, and immediately engaged the pillbox that had been firing on the landing craft. Our first round struck the embrasure. Our second round hit the entrance. The position stopped firing. We then engaged machine gun nests along the waterline, providing covering fire for the infantry coming ashore behind us. The DD tanks worked exactly as designed. We were firing before the infantry landed, giving them the support they needed." At Juno Beach, Canadian forces of the 1st Hussars landed DD tanks that proved decisive in breaking through strong German defensive positions. The beach defenses at Juno were among the strongest in Normandy. Extensive obstacles, interconnected bunkers, clear fields of fire. German commanders considered the position nearly impregnable against unsupported infantry assault. The DD tanks changed that calculation. They emerged from the surf while German defenders were concentrating fire on infantry in landing craft. The appearance of armor, where no armor should exist, caused momentary confusion that the Canadians exploited ruthlessly. The tanks engaged bunkers with 75mm guns, while infantry used the covering fire to advance through obstacles. Oberst Ludwig Krug, commanding the strongpoint at Courseulles-sur-Mer, reported to division headquarters at 01:15 hours. "Enemy armor is operating on the beach. Tanks appeared simultaneously with infantry, not hours later as expected. Our defensive plan assumed tanks would arrive after infantry had been dealt with. The armor is engaging our positions directly, suppressing our fires, supporting enemy infantry advance. Situation is critical. Request immediate reinforcement." The reinforcements never arrived. German mobile reserves were held back by Hitler's personal order, waiting for confirmation of where the main invasion would occur. By midday, June 6th, British and Canadian forces had secured all three of their beach objectives, penetrated several kilometers inland, and linked up their beachheads. Casualties were significantly lower than pre-invasion estimates, and armor support from DD tanks was cited in after-action reports as a critical factor in the success. The German perspective, comprehension. German commanders' understanding of what had happened at Normandy evolved slowly as reports filtered up through command channels. Initial reports of swimming tanks were dismissed as combat stress or misidentification. Soldiers under extreme pressure often reported impossible things. But as reports accumulated from multiple beaches, all describing the same phenomenon, comprehension grew that the Allies had achieved something German engineers had believed impossible. General Oberst Friedrich Dollmann, commanding 7th Army, reviewed after-action reports from beach defenders on the evening of June 6th. The reports were consistent. Allied tanks had appeared on the beaches simultaneously with infantry, not hours later, as defensive planning assumed. The tanks had provided immediate fire support, suppressing defensive positions and enabling infantry to advance. Dollmann ordered his intelligence staff to investigate how the Allies had accomplished this. The investigation over following days assembled evidence from multiple sources. Captured Allied soldiers who described DD tank training, examination of several DD tanks that had been disabled by German fire, and interrogation of captured tank crews. The technical assessment was sobering. Allied engineers had solved the amphibious armor problem using elegantly simple technology, canvas flotation screens, propeller propulsion, careful attention to launch parameters. The solution wasn't exotic or beyond German capability. It was creative application of basic engineering principles. German engineers could have developed similar vehicles if they'd recognized the tactical necessity and devoted resources to the problem. But German defensive doctrine had assumed such vehicles were impossible and therefore never devoted resources to developing them. The assumption that tanks couldn't float had prevented serious consideration of how to make them float. The resulting defensive blind spot proved catastrophic on June 6. General Oberst Alfred Jodl, Chief of Operations Staff at OKW, Oberkommando der Wehrmacht, reviewed the Normandy after-action reports in late June 1944. His assessment, submitted to Hitler on June 25, included remarkable candor about German failure. The appearance of Allied amphibious tanks on D-Day represented a significant failure of our intelligence and technical assessment. We dismissed reports of such vehicles as impossible based on our understanding of engineering principles. We failed to recognize that our assumptions about what was possible were incorrect. The result was defensive planning based on false premises. We prepared to fight unsupported infantry, but faced combined arms assault from the moment the invasion began. The Allied amphibious tanks did not win the Battle of Normandy by themselves, but they significantly altered the tactical dynamics in the critical first hours. Beaches where these tanks operated successfully, Utah, Gold, Juno, Sword, were secured with lower casualties and ahead of schedule. Omaha Beach, where most tanks sank before reaching shore, saw catastrophic casualties and nearly failed. The lesson is clear: we must not assume enemy capabilities are limited by our imagination. The Allies developed amphibious armor because they recognized its tactical value and devoted resources to solving the engineering challenges. We failed to develop it because we assumed it was impossible. This error in judgment cost us the element of surprise and contributed to our failure to defeat the invasion on the beaches. The human cost. The success of DD tanks at 4 of 5 Normandy beaches shouldn't obscure the tragedy of their failure at Omaha. 27 tanks sank in the English Channel, drowning 33 men who trained for 2 years to crew vehicles that never reached the beach. The crewmen died without firing a shot, trapped in steel coffins that filled with seawater in seconds. Sergeant Robert Patterson, one of the few survivors from Company B, 741st Tank Battalion, described the experience of escaping from a sinking DD tank. The tank was rolling in the waves when water started coming over the screen edge. We tried to bail it out, but there was too much water coming in too fast. The tank settled lower and the screen collapsed. The driver and co-driver got out through their hatches immediately. They could see what was happening and reacted fast. I was in the turret and had to squeeze through the hatch as water poured in. The tank was already going under when I cleared the hatch. I swam away as fast as I could. The suction from the sinking tank was pulling me down. I made it to the surface and inflated my life vest. The loader and gunner never got out. The tank sank in maybe 10 seconds, and they were still inside when it went under. I floated for almost an hour before a DUKW picked me up. I watched other tanks sink around me. Some crews got out, some didn't. The sea was full of men in the water, some dead, some alive, all mixed together with debris from destroyed landing craft. The memorial at Arlington National Cemetery includes the names of 33 tankers from the 741st and 70th Tank Battalions who drowned on June 6, 1944. Men who died without ever reaching the beach they'd trained to assault. But the DD tanks that did reach the beaches saved lives on a larger scale. At Utah Beach, where all DD tanks landed successfully, first-wave casualties were approximately 60 killed, remarkably light for an amphibious assault against prepared defenses. At the British beaches, casualties were similarly low, where DD tanks provided effective support. The contrast with Omaha Beach demonstrated the difference armored support made. Without DD tanks, infantry faced unsuppressed defensive fire and suffered catastrophic losses. With DD tanks, the same defensive positions were quickly neutralized and infantry advanced with acceptable casualties. The technological legacy. The DD tank represented a remarkably successful example of rapid military innovation under pressure. From initial concept in 1941 to operational deployment in 1944 required just 3 years. Developing a technology, testing it under operational conditions, manufacturing hundreds of vehicles, training crews, and integrating the system into amphibious assault doctrine. The success inspired subsequent development of specialized amphibious armor. The US developed the LVT, Landing Vehicle Tracked, a fully amphibious armored personnel carrier that could swim indefinitely and transition to land without modification. The Soviets developed PT-76, a light tank designed from the ground up for amphibious operations. Modern amphibious vehicles, like the American AAV-7, trace their lineage directly to World War II innovations in swimming tanks. But the DD tank itself was retired shortly after the war. The vehicles were too specialized, useful only for the specific mission of amphibious assault from offshore landing craft. The canvas flotation screen was vulnerable to damage and required careful maintenance. The propeller drive system was mechanically complex and reduced the tank's land-based reliability. More fundamentally, the tactical scenario that required DD tanks became less relevant. Post-war amphibious assault doctrine emphasized helicopter-borne vertical envelopment rather than beach landings, and when beach landings were necessary, modern landing craft could deliver armor directly onto shore without requiring vehicles to swim. The surviving DD tanks were scrapped or converted back to standard Shermans by removing the flotation equipment. A few were retained for museums, physical artifacts of the innovation that had enabled Allied success on D-Day. The final accounting, the Germans mocked the floating tanks because they violated assumptions about what was possible. Tanks were heavy steel vehicles designed to operate on land. They couldn't float, couldn't swim, couldn't navigate in open water. The physics seemed impossible, the engineering impractical, the concept absurd. They were wrong about all of it. The Allies developed DD tanks because they recognized that the critical vulnerability in amphibious assault was the gap between when infantry landed and when armor could follow. That gap, measured in hours in previous operations, gave defenders time to concentrate fire on unsupported infantry and massacre them before armor arrived. Closing that gap required armor to land simultaneously with infantry. That required armor to launch from offshore and swim to the beach. That required solving seemingly impossible engineering challenges, making 30-ton tanks float, propelling them through water, navigating them in ocean swells, and ensuring they could immediately fight upon reaching land. Allied engineers solved all these problems using canvas, propellers, compressed air, and careful attention to operating parameters. The technology wasn't exotic. It was clever application of basic principles. What made it revolutionary was recognizing that the problem needed solving and committing resources to solve it. German failure wasn't technical. Their engineers were capable of developing similar vehicles if they'd recognized the need. The failure was conceptual. They assumed the problem was unsolvable and therefore never attempted to solve it. Their defensive planning was built on the assumption that Allied armor would arrive hours after infantry, and that assumption shaped their entire Atlantic Wall strategy. On June 6, 1944, that assumption cost them the battle. DD tanks swam ashore at 4 Normandy beaches, providing immediate armored support that German defenders never expected to face. The psychological impact was devastating. German infantry prepared to slaughter helpless Allied soldiers instead faced 75 mm tank guns firing from vehicles that had emerged from the sea. The tactical impact was decisive. Beaches where DD tanks operated successfully were secured ahead of schedule with acceptable casualties. Omaha Beach, where DD tanks mostly sank before reaching shore, nearly failed and suffered catastrophic losses. The difference proved that the DD tank concept worked exactly as designed when employed under proper conditions. The strategic impact shortened the war. Allied success at Normandy established the Western Front, forcing Germany to fight on two fronts simultaneously and accelerating their defeat. DD tanks didn't win D-Day alone, but they contributed significantly to success during the critical first hours when the invasion could have failed. Oberleutnant Franz Gockel survived the war, captured by American forces on June 7, 1944, after his bunker at WN-62 was finally overrun. In post-war interviews, he described the moment he first saw DD tanks emerging from the sea. "We had been told the tanks would arrive hours later, that we would have time to destroy the infantry before facing armor. When I saw the first tank come out of the water, still wrapped in its canvas screen, I thought I was hallucinating. Tanks don't float, tanks don't swim." But there it was, crawling out of the ocean like some mechanical sea monster. More followed. 3, 4, 5 tanks, all emerging from the water and engaging our positions. In that moment, I understood we had lost. Our defensive plan was built on assumptions that were wrong. The enemy had brought armor to the beach in the first wave, and we had no counter for that. They mocked the floating tanks in our intelligence briefings. I remember officers laughing at reports describing Allied amphibious armor. "The British have built swimming tanks," they said, and everyone laughed because it was obviously impossible. We stopped laughing on June 6th. The impossible tanks swam to our beaches and helped destroy our defenses. By the time we understood what we were facing, it was too late. The invasion had succeeded, and Germany had lost its last chance to throw the Allies back into the sea. They mocked the floating tanks because the concept seemed impossible. Until the tanks stormed Normandy, swimming out of the sea, bringing 75mm guns to support infantry in the first wave, changing the dynamics of amphibious warfare forever. By then, the mockery had turned to fear, and the fear came too late to matter. The impossible tanks had already landed, and the Atlantic Wall had fallen.